The sixth question that we have is a very important question whose result you should remember. We have been given that the vertices of a triangle are given by position vectors A vector, B vector and C vector. We need to find out the area of the triangle. So as we know that for a triangle, suppose this angle is theta, this is A, this is B and this is C. Let this vector be A vector and this vector be B vector, that is BC vector is equal to B vector and BA vector is equal to A vector. Now in such a case, we can always write the area of a triangle to be equal to half of modulus AB into modulus of BC into sine theta. This is a formula because by solutions of triangle we get that for any triangle, half into this side into this side into the angle between two sides is the area of the triangle. Therefore by using similar logic we get this formula. Now this can be written as half into modulus of A vector, modulus of B vector sine theta. Now modulus A modulus B sine theta can be written as half of A vector cross B vector. Therefore you should remember this formula, that the area of a triangle is equal to half of represent this side by a vector, represent this side by a vector, take their cross product, then you will get the, and multiplied by half to get the area of the triangle. You can do it with any two sides. Area of the triangle here is not half this side into theta, it is half of this side into sine of the angle between the two sides. Now using this formula, we have the triangle as, let this be point A with a position vector of A vector, this is point B with a position vector of B vector, and this is point C with a position vector of C vector. So we need to find the vectors representing the two sides. Let us find out BC vector. BC vector is equal to C vector minus B vector. Now similarly BA vector is equal to A vector minus B vector. Therefore we can write area of this triangle to be equal to half of BC vector cross BA vector. Now we write down these quantities over here. We have to actually take the modulus at last. Let us solve it without writing the modulus over here. We will apply the modulus at last always. Now half of C vector minus B vector cross A vector minus B vector, this comes out to be equal to half of C vector cross A vector minus C vector cross B vector minus B vector cross A vector and plus B vector cross B vector. Now B vector cross B vector is 0. Therefore we get this to be equal to half of, this becomes A vector cross B vector, this becomes equal to B vector cross C vector, and this becomes C vector cross A vector. So this is a very important formula which you should remember. Also take the modulus at last. So this represents the area of the triangle whose vertices are A vector and B vector and C vector. So you can also deduce some things from here, that A vector cross B vector plus B vector cross C vector plus C vector cross A vector will be a vector which will be perpendicular to the plane of the triangle. This is because, as you have already seen, this can be written by half of BC vector cross BA vector. Now BC vector cross BA vector will be perpendicular to the plane of the triangle. Now BC vector cross B vector is represented by this. Therefore this vector will always be perpendicular to the plane of the triangle. Also you can deduce one more important thing, that if 3 points with position vectors A vector, B vector and C vector are collinear, then this quantity will be equal to 0 because the area of the triangle formed by them will be equal to 0. So therefore this can also be used as a condition, A vector cross B vector plus B vector cross C vector plus C vector cross A vector. If this quantity is equal to 0, then we can say that the 3 points with position vectors A vector, B vector and C vector are collinear. So these were the extra information that you could deduce from here. But our final answer is that the area of the triangle is half of A vector cross B plus B cross C plus C cross A.